This is home. A tiny blue dot, suspended in the endless silence of the cosmos.
But to truly understand our place, we have to take a step back. Further.
Our solar system, just a speck of dust in a great city of stars. And our galaxy, just one of hundreds of billions more, afloat in an unimaginable cosmic ocean. In this overwhelming vastness, one extraordinary mind dared to ask the biggest questions of all. Where did the universe come from? Where is it going? And from what is the fabric of our reality woven? The answer begins with the stage itself, a thing called space-time. It is not an empty void. It is a dynamic fabric that can be bent by the things within it. Matter, like our sun and the planets, tells space-time how to curve. And the curve of space-time tells matter how to move. That is the beauty of gravity. And traveling across this stage is the fastest, most fundamental thing we know: light. Its speed is a constant, the universe's ultimate speed limit, that nothing can surpass. This leads to a wonderful consequence. When the light from a distant star begins its journey, by the time it reaches our eyes, millions of years have passed. We are seeing a ghost from the past. So every telescope is not just a window into space. It is a time machine. All of this, from gravity to light, follows laws, the rules of the cosmic game. Gravity is more than a tether. It is a grand sculptor, gathering clouds of dust to build the galaxies. And from those clouds, it ignites the first fires, the stars, bringing light to the infant universe. But the universe is also ruled by other forces, invisible powers that operate on the smallest of scales. The electromagnetic force, binding atoms together, weaves the material world we can touch.
And the two nuclear forces, strong and weak, govern the furnace within the heart of every atom.
4 laws, 4 rules, harmonious and unchanging, that have allowed our universe to exist and to thrive. So let us look again at gravity. It is not some mysterious pull. It is simply a consequence of geometry, a dance between mass and space-time.
Matter curves space, and curved space guides matter. Simple and profound.
Our true journey has only just begun.
Stephen Hawking asked, if we rewind the cosmic movie, what would we see? Every galaxy, every star, all of it would shrink.
Earth towards a single point. Infinitely small, hot, and dense. It was the Big Bang. Not an explosion in space, but the very blossoming of space itself. From this moment, our universe was born, and the laws we have just learned began to take shape.
As the universe expanded and cooled, pure energy began to condense, forming the first particles of matter.
In its first few minutes, the universe was a hot, opaque sea of plasma, where light was trapped, unable to break free. But after nearly 400,000 years, a great event occurred. The universe became transparent, and the leftover glow from that moment is still visible today. It's the universe's baby picture, the cosmic microwave background.
And in this picture, there are tiny spots, almost insignificant irregularities, but they were the very seeds.
For all the galaxies, the stars, and for us, today.
And so, our universe was born from a singularity, a beginning point for space and time.
Imagine a star, much more massive than our sun, Its life is a battle between the outward push of nuclear fusion and the inward pull of gravity.
When the fuel runs out, the battle is over. Gravity wins, completely and crushingly. The star collapses under its own weight, warping space-time to an unimaginable degree. A black hole is born, a prison, even for light. Its boundary is called the event horizon, a poetic name for a place of ultimate peril.
This is the point of no return. Once crossed.
Anything that crosses this line, from a speck of dust to a star, shares the same fate. Relativity shows us something strange. If you watched someone fall in, you would see their time slow down.
Slowing so much they would appear frozen for eternity at the event horizon, fading over time.
But for the astronaut themselves, nothing special would happen at that moment. They crossed it long ago and are now plummeting toward the center.
Inside, gravity becomes extreme, a force beyond all known rules.
And everything would end at the center. Another singularity.
A point of infinite density, where space and time cease to exist.
He realized that on a quantum level, empty space is never truly empty. It fizzes with pairs of virtual particles, constantly born and destroyed. And when this happens right at the edge of a black hole, something amazing can occur.
One particle is captured, while its twin luckily escapes. To an outside observer, it looks as if the black hole itself is glowing.
This Hawking radiation, though incredibly faint, causes the black hole to slowly evaporate over trillions of years.
It gets smaller, hotter, and eventually it will shine brilliantly.
Until its final moment, when it gives back all it has taken and vanishes into the cosmos.
But this raises a profound puzzle. What is the fate of everything that fell inside?
Is the information that made them what they were, a book, a star, erased from the universe forever?
This is the black hole information paradox, the sum, a battle of physical laws that challenged one of the greatest minds of our time. Perhaps the information is not lost, but re-encoded and released in a new form, a mystery left for the future to solve. We have journeyed to the beginning and the end of time, but one final question remains. Why do we remember the past, but not the future?
Why does time seem to flow only forward and never back? The answer lies in one of the most fundamental concepts in physics, called entropy. Entropy, simply put, is a measure of disorder. And in the universe, disorder always tends to increase. There are infinitely more ways to be disordered than there are to be ordered.
A sandcastle will always be washed away into the disordered sand. It never builds itself from the beach. So it is with our universe. It began in a state of incredible order, very low entropy, at the Big Bang.
And ever since, the universe's entropy has been constantly increasing, like a river flowing always downstream. This constant increase in disorder is what creates the flow of time that we experience. The past is the place of order, the future the place of disorder. That is why the arrow of time flies in only one direction.
So, where does that arrow's journey, Untamed, the universe's journey, finally end? The most likely scenario, based on what we know, is the Big Freeze. The universe will expand forever. The last stars will burn out their fuel and fade away, becoming cold, dark embers. Even the great black holes will evaporate over trillions of years, returning their energy to the void. leaving behind an empty, cold, and eternally dark universe. A final silence.
Of course, there are other possibilities, such as the Big Crunch. Of course, there are other possibilities, such as the Big Crunch. Everything would end as it began, in a hot, dense singularity, perhaps to begin a new universe all over again. A future of ice, or a future of fire. For now, we cannot be certain.
And perhaps the answer to the ultimate fate of the cosmos is not as important as another truth.
The truth that this universe is vast, cold, and indifferent to our tiny existence. But in all that infinite indifference, on one small speck of dust, something extraordinary has happened.
We, creatures of stardust, can understand the very universe that created us.
We have found the language of the cosmos, the laws that allow us to read its story. In a universe governed by chaos, we create understanding. What a triumph.
And that, to me, is the greatest triumph of all. And that, to me, is the greatest triumph of all.